Hello, this is Jeffrey Fox here. I'm the instructor of the Big Data Applications and Analytics course, and we're doing lesson 4 of the second unit in the Sports Informatics / Sports Analytics section. So let's get on with the lesson. It's a relatively short lesson, and it comes to a discussion of this whole unit is on baseball, and here we're looking at some of the ways of using video in baseball. We did PITCHf in earlier this unit, and now we're going to do the fielding, the batting, and the catching, and also mention an alternative from Major League Baseball. These ones here come from Sports Vision, the company. All right, so here we look at FIELDf, and it uses, you can't really tell exactly what it does, but it's here are a couple of good references, one from the company and one from a professor of physics at Illinois, and it uses clearly similar video technology to the original PITCHf, and instead of tracking pitches, it tracks the ball as it's hit and what the fielders do, and it produces nifty pictures like this, with this fellow catching a brilliant catch. And here we have some statistics as how fast he ran, the distance, and how efficient that distance was. He really went straight from where the ball was going. He judged very correctly where the ball was going to land and hit it directly for it. And here is some similar types of pictures of, here's the actual baseball runners, and here is the fielder running, and here's the straight line, and here's the actual path, and this ball was hit actually right along the foul line here, but I gather it's probably a fair ball, and this is just a broad material. And notice this is a mixture of, here we're just seeing visualizations, what we call spatial visualization, which is the initial thing to produce. But here there's some actual analytics. It tells you how efficient the fielder was. And of course, using these numbers like the total distance the fellow had to run, you can actually compare the fielding rather precisely with that of other fielders. So you can say at this type of distance, the probability of catching the ball is whatever it is, which obviously goes down as the distance to run goes up. So this allows you to do very precise sabermetrics type statistics on fielders. Here is an overall picture of the types of things FIELDx does. Comes from this article in Hardball Times Baseball. I actually haven't read that article. You have to buy the book. But on the web you can find this picture and the types of information. Here's the range. We saw that actually on the other picture. Here's a nice. I told you we can estimate probabilities because we know we have so much data. Here's a high probability, 85%, a low one, 29%. And here we have ranges of player ranges as a probabilistically saying you can get to this range and catch the ball with somebody with a 10% efficiency. Not so good. Whereas here it's the blue. Well, actually, blue is not so far, and the 50% range is not so good. Doesn't so. Anyway, you'd have to read. Here, this one is obviously easy. This one is hard, and you can obviously quantify all of this in a very precise fashion with this type of data. And this is what goes into your this type of analysis. You might put into your very detailed determination of WAR, because that includes the runs garnered in the field by catching difficult balls. Your WAR will go up because you're saving runs. Here is alternative technology comes from this company, MLB Multimedia, MLBAM, and it's mentioned a little later on in this presentation. You can see this fellow again producing a brilliant catch with the same type of statistics we saw before, and we actually have the ball highlighted. I gather this particular WL BAM analysis is more detailed than that from Sports Vision. Obviously, if you want to do something after somebody else, you better do it better, otherwise there's no point. And here you actually see this done in real time. The person is starting off here, and this other field is starting off there. We can see this fellow has slightly longer to run than this fellow, and this is the fellow, Jason Hayward, who actually does the catch. This fellow actually, remember some of the other people at top speeds are over 21 miles per hour. Here we only got to 18.5 miles an hour. But they start pretty quickly. Their reaction time is very good. And this fellow is obviously traveling faster and accelerating faster. But maybe this fellow just slowed down because he could see that Hayward was going to be the one who caught it. And here we have, of course, these runners here. And actually, I'm not certain whether that's a fielder or a runner. This is probably a runner because it's the white, and this team, the fielding team's in black. Okay. So MLB Advanced Media has this technology which is similar to that from Sports Vision. And that's what they announced at this Sports Analytics Conference. I mentioned this MIT Sports Analytics Conference, full of useful information. And it's separate from Sports Vision, which probably they want to, I have no idea of the politics, but I imagine Major League Baseball is trying to make as much money as possible and own as much of the technology as possible. It's interesting. I mean, here's some interesting technology: 2,000 frames per second for the ball, 30 frames per second for the much larger images you need for the players. And we saw information on how fast they react. And this is the type of broadly how advanced media does not just the fielding, but pitching and catching. Well, catching is of course part of fielding. But here's we have the pitcher. He's a 98.1 mile per hour throw. Interesting information about the spin rate. Pretty fast. And again, we have this maximum speed. Remember, the other one was 18. Actually, ran about the same distance, though. I think the fellow was Hayward. He only got out to 18 miles per hour. But look at the efficiency of this route. Obviously, the person really anticipated where the ball was going to go very, very well. So this type of, obviously, these types, this is all visualization to some level, because you now need to take this data which you get, which are huge. It's a very, once you have a lot of this data, you can produce statistics quantifying the performance of every player in Major League Baseball, and you can use that to decide who is the right fielder to play in a particular ballpark. Because again, if you have a large ballpark, you probably need players who actually can run further and things like that. So these numbers are shown here for visualization, but obviously can be used in a deeper fashion to produce decisions in the way we saw for sabermetrics and WAR earlier on in this section. So here we have a HitFX. We're going back to Sports Vision now. They have all the technologies for everything. Presumably based on the same general video technology. And again, the HitFX, not surprisingly, uses actually the same hardware as pitching, because if you can track the pitch, you can presumably track the actual action of the hitter, and you may not be able to track with the same. The same cameras presumably will not tell you where the ball goes, but they'll certainly tell you how the batter hits and with how the batter swings and things like that. So here I pointed out, when you do video like this, you convert the video into numbers, such as the contact point, the speed of the bat, the angle, and the direction in the field. These are the ones that allow you to do physics, apply it to a particular ballpark with a particular humidity and a particular air density corresponding to its height, to decide whether in that ballpark this particular hit would have been a home run, a catch, or what have you. And so you can then do, we went through this analysis of Vince Gennaro of pitchers versus batters. This is the type of data that can be able to make that analysis much more precise. And we've already discussed how venue, pitcher, batter, game situation, whether you're just about to get, you're desperate to get into the playoffs or desperate to win the World Series. All of that can be combined with this data to make decisions which are worth, as we pointed out, $5 million a win. Pretty good numbers. Here is another talk I found, had some HitFX data from April 2009, and it's looking at the initial batted velocity here. Here's high velocity, likely to go far. Here's the launch angle. These ones here are negative. These are balls heading down, which obviously is possible. If it goes a really high angle, they're going to just drop in front of the batter. Here's a fly. Well, here it's just a pop-up, goes straight up in the air. And these ones here are too high an angle, so they're caught, popped out. These ones here, these are lineouts here. They're caught in the field. And here we have singles here. Home runs, which are these ones here. These are home runs. They're actually reasonably focused where they are. Although, of course, the way it's plotted, you really need to see which colors underneath which other color. You just get presumably the dominant color here. So this type of information can be used again for visualization to decide whether the batter's tending to hit them too far up or needs to to correct swings, and again to take the result in one ballpark and convert it into a result in another ballpark, because you know in particular one of the numbers is how far the ball went, and you can see whether it's out of the ground or in the ground, namely a home run, or whether it's actually going to land in the field in a particular stadium. And this sort of classifies the types of hits. We saw that, I pointed out, the pop flies, the ones which just sort of, they don't go up and straight down. They actually go into a nice direction, but not quite good enough for a home run. The home runs have to be hit at a slightly lower angle. And of course, triples, doubles, and singles are also, these are the difference between a line out and a double just depends on whether that particular ball goes near a fielder, or what height it is when it reaches the fielder. And so there's some subtle differences here, but there's a reasonably interesting collection of points here. Here, of course, we have the ones with very negative launch angles. They just go straight to the ground and are ground outs, easy outs. Okay, so that shows how we can really get a very precise measure of the quality of a hit and the nature of the hit. And this is the final slide of this set, and we look at CommandFX, which sounds very impressive, and it also uses the same technology. The poor old catcher is just standing or crouching behind the batter. So if you can recall what the batter does, you can do what the catcher does, and you can look at, obviously again, you can convert your video into a location of the glove at the time the pitcher releases the ball and how it moves to catch the ball if it's missed by the batter. And so you can basically track the glove in 3 dimensions, and you can convert that into again the types of way the catcher is calling the game, calling the types of pitches and things like that. And look at this. So this is pretty interesting. Every catch since 2010, they already had this data on tape, or however they stored it, their digital video, and they just went back and calculated all this information, allowing you to then not to do a complete analysis now of pitcher, batter, and catcher from this basic pitching data originally designed for pitching. And then we saw earlier how the same type of methodology, but just with obviously videos with wider field of views, and or maybe the ones that track the ball actually has a small field of view, but that field of view is rapidly, dynamically changed, so it tracks the ball. And they have this then from 2010. So they have by now 5 years worth of data at the end of the 2014 season. So that's pretty good. Okay, so that's the end of our discussion of baseball. We went through numerical numbers and the different ways they could be combined, and either in a very deterministic fashion, determined by the user or by clever machine learning algorithms. And then over the last few lessons, we've shown how you can use video and to visualize what all the different people who make up the different types of players are actually doing, and then convert that into more numbers, which can give you more precise measures of the performance and capabilities of players, which all goes in to more precise WARs and then more precise understandings of how to play the game, which pitcher to use, and which fielder to use, and which batter to use, and in principle, which catcher to use. So and how the catcher, and whether a catcher has particular difficulties with a certain pitch, you could obviously find that out. So thank you very much. That's the end of this discussion of baseball.